When I was a medical student, the term cognitive puzzled me. It seemed to encompass everything the brain did, yet remained frustratingly vague. Understanding what it truly meant required first understanding what it wasn't: a reflex. Consider a simple reflex: your hand jerking away from a hot stove. It's immediate, automatic, predictable. Input triggers output without consideration. But cognition, that's where things get interesting. Chapter 1: The Architecture of Choice. Cognition begins where reflexes end, with choice. When your brain holds multiple possibilities and selects among them, that's the birth of a cognitive act. This capacity to choose, to decide, forms the fundamental unit of all higher thought. But here's what's remarkable: these decisions don't always result in action. Your brain can simulate scenarios as if it was going to act, weigh the options, and update its strategies entirely internally. This playing of simulation is what we call thought. This act continuously refines what I like to call our choosing algorithm. So, if reflex is an automatic response, something opposite to it that requires consideration and choosing between options, this fundamental unit of action is called decision making. According to modern neuroscience, this act of deciding, no matter how small it is the fundamental that builds consciousness. And rightly so. When decisions are stacked, they form reasoning or planning, and when all of these are stacked together with each other, the emergent experience is consciousness. This domain is what we call cognition. So, to build on this, to understand consciousness, we must first understand how we decide. Chapter 2: Your Dynamic Algorithm. Think of your brain as running a sophisticated algorithm, not a fixed program, but a living system that constantly evolves. Every moment it evaluates sensory input against prior knowledge, predicts outcomes, and makes choices. This algorithm isn't just processing, it's learning, adapting, becoming. What shapes this algorithm? Well, experience adds new connections, knowledge provides context, emotions assign values, priorities shift the weights, and seemingly this algorithm is updated and meant to make best of decisions. This seems too simple. The approach of decision making isn't always about being objectively correct, but it's about making the right trade offs for your specific goals. Paradox of experience. Consider a fascinating paradox. In medicine, diagnosing cancer requires a strategic choice. Set your detection threshold low, and you will catch more cancers early, but creates more false alarms. Set it high, and you will reduce anxiety inducing false positives, but risk missing real cases. Neither approach is wrong, each reflects different acceptable trade offs. The beauty of this, as mentioned before, is that these things are not always hierarchical but preferential. What I mean is that hyper accurate analysis can eventually lead to trade offs in other domains of decision making. For example, the more experienced mind may simulate many variables and anticipate so many potential pitfalls that it can lead to inaction, kind of paralysis driven by knowledge of possible pain. NVIDIA CEO Jensen Huang describes this for beginners as the superpower of not knowing. The idea that beginners unaware of full extent of pain and complexity ahead are more likely to take bold leaps. So, it's not always right to say that deeper or more extensive analysis leads to better outcomes. often it ends up diminishing the value of possibilities, especially when it comes to a new or novel ideas. That's why the objective of decision making is not always to be objectively correct, but to choose the right trade offs that allow you to achieve your goals. This also adds another layer of choice, not only in options but the approach itself. And all of this built into the algorithm of different people are based on life experiences, knowledge, and different values, which of course is different for everyone. That is what makes consciousness so unique. Chapter 3: The Three Phases of Decision. Our brains make three fundamental types of decision: perceptual decisions based on sensations, value based decisions based on preference, and reasoning based decisions based on logic and reasoning. Chapter 4: The Neural Symphony. Perceptual decision making is the process of identifying a signal within the noise and determining whether that signal has reached a threshold level strong enough to be recognized. This involves breaking down incoming sensory input into patterns of neuronal firing that match pre existing internal algorithms. The sensory stimulation creates a neural representation of the signal in the brain, which the system then tries to compare and match. Though the exact mechanism of matching remains unclear, but we will discuss some possibilities later on. Something else that's interesting is the very neural activity involved in forming this representation can also inject additional noise into the pattern itself, making the process less precise. Not always does the same stimulus get converted into the same neuronal representation. There might be a degree of error or variability in how the brain encodes identical stimuli, further leading to differences in neural representation, even when the algorithm and input remain unchanged. This difference, referred to as variance, can cause errors or shift decision making points unpredictably, adding another variable that influences decision making. It's often impossible to tell whether this variability is a result of real signal itself or a byproduct of internal brain noise. This can be one of the major reasons for wrong decisions even for a person with a good algorithm. The algorithm or criterion used to detect and interpret signals is not fixed. Yeah, this is what fascinates me because this is what's different from, let's say, a machine which has fixed algorithm or procedurally changing algorithms with limited range of possibilities in its outcome. But life, consciousness, they have unpredictability baked into them in all the steps. This baked in unpredictability is what defines consciousness. Another profound insight is that neuronal computation is fundamentally comparative, not just in the narrow sense of selecting between options comparative, but in the broader sense of integrating, associating, predicting, and evaluating patterns of activation. When the input pattern closely matches a learned or expected pattern, it crosses a functional threshold, triggering output from downstream neurons. This acts like a distributed decision gate, where the threshold isn't a single number but a network level pattern requirement. So, the decision depends on how many neurons are activated and which neurons get activated and how strong are they activated. That is, synaptic weights, connectivity. So, in order to compare between two impulses that are separated in time, the neurons are able to store these impulses and act like a working memory. This is persistence like persistence of vision, where the rods and cones hold the information for some time, even with absence of stimuli. This helps the neurons further to compare between different signals that are separated in time and in space of brain itself. Any new information is understood, in fact, based on the information that is already stored. This comparative nature of brain helps brain to understand different facts very fast. But there is a trade-off. Newly novel insights become rarer as new things are just derivative of already established concepts in our mind. It is perhaps for this reason that Einstein's theories of time and space were so revolutionary. They broke free from comparative framework and explored concepts in their own fundamental terms. In this light, consciousness might not be viewed only as awareness, but as a dynamic system that is a collection of interacting decision-making cognitive algorithms trying to do his or her best in this world.